Hey, this is the video lesson for section 7.6. So in this lesson, we are going to do some application problems of quadratics. So these might look initially a lot like the previous application problems we've done. They should look sort of familiar. But when you set up the equation, you always get a quadratic for these. You won't always know in a test or something if it's going to be it, but when you set it up, you'll see, oh, this is a quadratic, then you solve it like a quadratic. If you set it up and it's not, then you solve it like it's not. I mean, they don't have to have a sign that says which one it is. So our book kind of gives a general attack plan for word problems. Every book is a little bit different, but they're mostly the same. In essence, they're the same. And the first thing is you have to read the problem until you understand it. Now this says read it at least twice. Well, if it takes more than two, read it more than two. You read it until you understand what they're saying. And maybe that takes trying to say, okay, what do I know in my life that is like this? Or what do I know? Try to make sense of what it's telling you in that story problem. You decide what is being asked for. Typically, when you find the question and it says, what are the numbers? Or find the numbers, or find the sides of the rectangle, or find the lengths of the yard, or something, that is what you're going to make a variable. And in this case, usually there's two things, but we want only one variable. So there should be some relationship between them that you could make it, you could write them both, but use only one variable. And then you can make a chart, you can do a diagram or a table or whatever to relate these things together so that you can make an equation. And then you solve the equation and you always check your answer. In a word problem, you always check your answer because the answer you get might be some crazy thing that doesn't make any sense. And sometimes you can do everything right and you get an answer that doesn't make sense and you have to throw that one out. Okay, so here's the first problem. One number is 4 more than another and the sum of their squares is 296. What are the numbers? Okay, so we're talking about two numbers and one is 4 more than the other. Right? And that is the question, right? What are the numbers? So that's what we're going to make our variables. And we want to write them both with one variable, but somehow use it to write both of them. Okay, so our variables are going to be, if you choose x, you don't have to choose x. You could choose n or whatever number you want. But the smaller one's going to be x, then the bigger one's going to be x plus 4 because it says one is 4 more than the other. All right, now it says that the sum of their squares is 296. So this sum means we're adding two things together, right? And the squares means we have to square those things. So we're going to take x and we're going to take x plus 4 and we're going to square them and we're going to add them together because that's the sum. And that's got to equal 296. So there is our equation. And now we just have to solve it. So we're solving it just like we did in 7.5. We have to get it equal to 0 and we have to get it all factored. So that means we have to multiply out the one that's squared already. And take note that when you multiply out x plus 4, you get this whole thing, right? You don't get x squared plus 4 squared. Remember, you have to do the whole x plus 4 times x plus 4. So here's our x squared. I kept that one. This one became this quadratic. And then now I have to just add them all together and put everything on one side of the equation. So now I'm going to factor. And you can see that the first thing I'm going to do is I'm going to take out the common factor, which is a 2. And now we're looking at finding two numbers that multiply to be negative 140 and they add up to be 4. So it's negative, so one's positive and one's negative. But you see that if I just started at 1 and 140, that's going to be like 139. I have to get that difference down to 4. So I want to skip a few. I could try out any along the way that I think I have. Since I have 140, it does make it easy to try 10 and 14, because 10 is so easy to do 10 into something that ends in a 0. And they are 4 apart. So we could go right to there. I want the bigger one to be positive because it's got to add up to positive 4, and the negative one to be the smaller one. All right, so there's how it factors. So, as the note says, the constant is not going to affect the answer because it can't be 0. It's a 2, right? It's not 0. It can't be 0. It's a 2. There's no variable in it, so I can't solve for 0. So the 2 doesn't affect the answer at all. We just have x plus 14 and x minus 10. So we solve that. When we solve, we get x is negative 14, and then if I get my bigger one, so these are my two numbers, right? These are my two numbers, negative 14 and negative 10. On the other side, I get 10 and 14 when I plug it in and get the other one. So these actually both work. Nothing in our original problem said anything about them not being negative. They could be negative. They just said they were numbers. And if you check them, they both check. Okay? All right, here's the next one. In an orange grove, there are 10 more trees in each row than there are rows. How many rows are there if there are 96 trees in the grove? Okay, so what does that mean? There are 10 more trees in each row than there are rows. So you might just try picking some numbers. Like, let's say there are 2 rows. Then according to this, there are 10 more trees than there are rows. That means there are 12 trees. 2 rows with 12 trees, right? So if you're thinking about, you have these, I ran out, and you'd have 2 of these rows, right? With 12 each. Then I would have 24 trees. So I could just keep trying until I got a 96. But let's just use some variables. So whatever number of rows I pick, so if there are 3 rows, then there would have to be 13 in each row, right? If there are 4 rows, there would have to be 14 in each row. So I'm just going to say R is my number of rows. And so how many trees are in each row? Well, that means R plus 10. So that way we have this variable, R, the number of rows. And actually that's what it asks for. How many rows are there? So that's what we're trying to find out, what R is. Okay, so as we set up that equation, remember when we're figuring out how many are here, this is making an array. And so it's 3 times 13. That would give us how many are in that one, or 2 times 24, remember? So it's R times R plus 10. That is my equation. So this is the number of rows, and this is the number of trees in each row. All right, so we multiply that out. We'll put it in standard form. No, they have a picture. And now we have to solve. So we're trying to solve. We're finding 2 numbers that multiply to be negative 96, but add up to be 10. So it's negative, so it's positive and negative. And sure enough, if I start, I get 95. Well, that's way too big, so I don't want to try every number, so let's skip down a bit. Well, I guess we could skip to 4. It's going to be 4 and 24. But that's still 20, so that's still too big. So 6 might go in. What do we think about 6? So 96 divided by 6 would be 16. And those are 10 apart. So we have positive 16, negative 6. Those would be my two numbers. All right, so either r minus 6 is 0 or r plus 16 is 0. In which case r is 6 or r is negative 16. Now, think about what r is. What is wrong with that? So there are 6 rows, and I can throw out negative 16 because, why? We can't have a negative number of rows, right? That one really doesn't make sense. So it's 6 rows. That would be our answer. Okay, a rectangle has area of 135 and perimeter of 48. What are the dimensions of the rectangle? So they give us 2 bits of information. This perimeter, though, tell me, what is the perimeter? I hope you're saying to yourself it's adding up the outside edge, right? So we have area and we have perimeter. So area is length times width. Perimeter is 2 times the length plus 2 times the width. So since perimeter is 48, we could take 2 out of that whole thing, and we just get that 24 is equal to length plus the width. So I know that they add up. So if you think about your rectangle, if this is length and this is width, but they have to add up to 24, I could write 1 in terms of the other, saying that if this is, then length would be equal to 24 minus width. Or I could have gone the other way, right? So there's my rectangle. So these are my 2 sides of the rectangle. Because remember what they asked us? What are the dimensions of the rectangle? Now, we're saying one specifically width and length, but in the end, it really won't matter because we should get 2 answers, right? One with each one being length or width. And anyway, as we get there, we'll see. Okay, so we set up the equation according to the area, right? So the area was 135, so that's length times width. All right, so why don't you pause the video and see if you can solve this yourself. Multiply it out so you have it in standard form and then factor it. Okay, hopefully you were able to do it. So hopefully you found that when you simplified it, you wanted to have a positive in the first. Remember that we always talked about the fact that the x squared term, or in this case w squared term, should be positive in order for all of our little rules to work. So I'm going to put it on the right hand side. That's what I did. You could still have done it on the left hand side, but then you would have a negative for that negative right there. So then you would need to multiply through everything on both sides by -1, and you'd get the same thing. Okay, so we're looking for 2 numbers that multiply to be 135, but add up to be -24. And this is a positive 125, so both of our answers have to be the same sign, so they're both going to be negative. So we can just start looking. I'm going to go for 5. 135 divided by 5 gives me 27. Okay, so that still adds up to 32, so that's not going to work yet. We need to go a little bit more. So I know that in 135, no even numbers are going to go into an odd number, so I don't have to worry about 6. And 7, you could try 7 on your calculator, but you can look at these two numbers, 5 and 27, and 7 doesn't go into them, either one of them, so it's not going to go in to the whole thing. And 8's even, so it doesn't work. So the next one to try is 9. So 135 divided by 9 is 15. And ta-da, that one adds up to 24. All right, so those are my two numbers, w minus 9 and w minus 15. And then I solve each one of those. And you notice that in both of these cases, we have 9 and 15 as the length and the width. Typically, we generally think about length being longer than width, and so we'd probably go for this one, but it really doesn't matter. In fact, it just asked for the dimensions, so we can say the dimensions are 9 by 15. Okay, a man wants to build a block wall. It's shaped like a rectangle along 3 sides of his property. So there are only 3 sides. So the other side is something else. Maybe it's the side of his house, or maybe it's a river or a road. He's not fencing it in. He's just, maybe it's already got a different fence on it, but he only wants to fence 3 sides. Okay? 180 feet of fencing is needed, and the area is 4,000. What are the dimensions? So there's the question. What are the dimensions of the lot? So that's what we need to be variables, right? We need a variable for these 3 sides of the lot. Well, 2 of them are the same. So let's just make those both x. Okay, and I know that they all add up to 180. So I have x plus x, so it's 2x, plus whatever's here has to equal 180. So if I just subtract 2x from 180, I'm going to get what's here. So 180 minus 2x. Okay, so those are my dimensions in variables, right? So now, and I used this 180 there to get that because we were just talking about length. So now I want them to multiply to be 4,000. Okay? All right, so there's what we had, and we have multiply the width and the length. That's going to equal 4,000. So try again, pause the video and see if you can finish solving this. So here we go as we finish. Again, we have that negative x squared term, so I'm going to put it on the right-hand side so it's positive. And we have a common factor of 2, so I'll pull that out. And now we're left with this quadratic, and we have 2 numbers we've got to find that multiply to be 2,000, but when you add them up, they're negative 90, so they're both going to be negative. So if we just start looking, I mean 10 goes in, if we look at 10 and 200, that's going to be 210, so that's way too big. So let's go to 20. 20 and 100, that's going to be 120, which is getting closer to 90, but still too big. So we could go up, we could try 25. 2,000 divided by 25 is going to be 80. So it's still 105, so that's still too big. So I don't think 33 won't go into that, so let's go for 40. So 2,000 divided by 40 gives me 50. Aha, so there we have these two that add up to negative 90. All right, so there's how they factor. We solve by taking each one of those. So it's either 50 by 80. So this would look like 50 and 80, and that would add up to 180, right? Or this one would look like 40 and 100, and that would add up to 180. So either one of these will work. I think I just wrote right where they're going to do it. All right, here's the next problem. I think this might be the last one. The sum of the squares of two consecutive positive odd integers. So the sum of the squares, we already talked about one of those, so that's the same idea, the sum of the squares. Now we have two consecutive positive odd integers. All right, so we've talked about consecutive integers before. One right after the other, right? And these are odd numbers. So remember, if you have a number like, say, 3, the next odd number would be 5, right? We would add 2. If you had an odd number of 11, the next odd number would be 13, so that would add 2. So whatever variable we pick, we will add 2 to get to the next odd integer. So if we let n be the first one and n plus 2 would be the next one. All right, so this is going to be just like the other one. So pause this video and see if you can set up using these two variables for the two numbers, set up the sum of the squares equals 202. Okay, so hopefully you set it up like this, and then we had to multiply it all out so that we could get it equal to 0. Combined, then we have a common factor of 2, so we'll pull that out. So now we're looking for two numbers that multiply to be negative 99. And they have to add up to be 2. So this is a positive and a negative, and they're 2 apart, right? So there aren't a lot of possibilities for 99, but 9 definitely goes into it. Let's see what 9 fits in. 9 and 11, those are 2 apart, so that's the one we get. If you didn't start with that, that's fine, but you would get to it soon because there aren't that many factors in 99. 3, 1, 3, 9, that's, and 33, right? That's about it. All right, so factors to be n minus 9 and n plus 11. So it's either 9 or negative 11. Remember that this time they didn't say any integer. They said it was a positive. If you remember back at our thing, it said a positive integer, right? So negative 11 is out. So it's 9, and then the next integer up would be 11. So those are the two integers that we get. And we could check it. Okay. All right, well, that's it. I didn't give you any practice problems. Do the homework. That will be your practice problems. And I will talk to you in class about any questions you have on the problems on your homework.